Chapter 10, guys. Finally made it. Round. Y equals ax squared plus c. What? Well.
Wait,
It's
no,
no kind of stuff.
we can say we didn't.
I'd say the class did all right. So if you didn't do well, pick it up. All right, y equals ax squared plus c. Notice bx is not there. It doesn't mean that we won't put bx in there. That'll happen. Just we're specifically dealing with a specific type of problem here. And we're graphing these things. So today, we go back to our general way of graphing, the very basic way of doing things. What is that? What do we do when we want to graph something we don't know how to graph? What do we use?
Y equals mx plus b.
No, that's given a formula and stuff. I'm saying the very basic. What's the first thing we do? No. A table? Like what do you mean?
Like an x, y.
Yeah. That's the very basic thing. When we want to graph something and we've forgotten all those formulas and all those neat tricks you've been taught and you all learned, go back to just plugging in values. So let's do that. Example A. This is important because we're going to graph all these. I have 1, 2, 3, 4, 5 examples, and we're going to put them all on the same graph.
Is that including A?
So I'm going to put the graph right here.
It's a big graph.
Half a page. Yeah.
Can I go get my graph paper?
Yes. Okay, so here's the basic example. Y equals x squared. A is 1. It's positive. C is 0. B is 0. Okay? So now let's all graph it. Here's the problem, the numbers I want you to use to start out. -2, -1, 0, 1, and 2. Everybody do those right now. All right, you should have gotten 4, 1, 0, 1, 4.
Wait. Wouldn't it be negative because the sign isn't attached?
It's inside the parentheses.
It's a parenthesis.
So y equals, you substitute, so whenever you substitute, you put parentheses in, we're going to square that.
Okay. I didn't think you put parentheses
Yeah.
there.
All right, so let's graph that, shall we? -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. Notice this is symmetrical. Now, these are parabolas, so it's not a point at the vertex. It's a curve. All right? Make sure it's curved at the vertex the best you can. That's A. Example A. Okay? Example B. Everybody do this one. Y equals 1/2 x squared. xy, -2, -1, 0, 1, and 2. Everybody figure it out? Okay, when you do that, everybody good?
Yes.
Okay, so we have -2, 2, -1, 1/2, 0, 1, 1/2, and 2, 2. Notice what happens. Make sure it's not pointed at the vertex. What do you notice? difference of A and B?
It's wider.
Wider. What's the difference looking at the equation?
It's smaller.
A is
Bigger.
less than 1. Between 0. On B,
What do you mean?
lowercase a of ax squared
It's
sorry,
less than.
is a fraction between 0 and 1.
Oh, yeah.
And this makes y increase slower, so it goes out more. Okay? Example C.
Oh, no. I see.
Y equals 5x squared. Everybody check to see what that does. What do you think it's going to do?
It's going to get skinnier.
Skinnier because y increases rapidly. Okay? -2, -1, 0, 1, and 2. Everybody do that? Make sure you do the exponent first. Then graph it. Have you already done? It is positive 20, by the way. Oh, yeah. So -2, 20. -1, 5. 0, 0, 1, 5, and 2. So again, make sure it's curved at the vertex. And this is example C. And C is definitely increasing rapidly. Everybody catching on? Let's see if you catch on to this. Example D. What?
Not ready.
Y equals -3x squared. Everybody do it. And plot it.
Oh, yeah. 1%.
Copy. Graphing a lot. I'm alright with you drawing your graphs, but it'd be nicer if you had your graph paper.
Should we put our whole assignment on a piece of graph paper, or do you want us to have a piece of paper and a graph paper? Is there anything that needs to be done just on a piece of paper?
This is what you're doing today.
And this is all.
I would like to see your XY charts. So
I'll
if
put
you-
them on the graph paper.
That's fine. Alright, so that's 4, that's -12, 1, -3, 0, -3, and -12. Everybody get negatives? So at -2, we're down to -12. And -1, 3, 0, 0, 1, 3, and 1 negative. 2 -12. Again, make sure you're curved at your vertex. That is key. So far, so good, huh?
Yeah.
Pretty simple? Yes, Cameron?
So if you have like -2 and 2, those answers are always going to be the same. We just
Okay, great question. Which takes me to the next example. His question is, are these going to be the same? Are your y values going to be the same at the same x values? But opposite signs. No. That's only if your vertex is at 0 or on the y-axis somewhere. If your vertex is anywhere on the y-axis, then yeah, those will be close to the same. If it's at 0, okay? All right, that's important. I shouldn't say on the y-axis, but at 0. All right, so here's the next one. So I'm glad you made that statement or ask that question because this will change things a little bit. So y, notice what happens to your responses. Y equals negative x squared minus 2. Make sure everybody in here gets the right signs. Remember, the negative is on the negative 1 as the coefficient. Notice we haven't done any bx terms, the middle terms. So to help some of you out, let me just write it out for you. That's a negative 1 times negative 2 squared minus 2. That's how you should look at that. Negative 1's in front. You got to square what x is first. Then multiply by negative 1, then subtract the 2. Okay? So that's 4, negative 4, minus 2 is negative 6. Okay?
What do you have to say?
Yeah. Because it's on the y-axis. Vertex is on the y-axis. It will not be that way when it's not on the y-axis.
How do you get it off the y-axis?
You'll learn that in another lesson. Okay, so let's plot this. Negative 2, negative 6. Negative 1, negative 3. Same as that one. So this is almost like D, but it goes out a little bit wider. That's E. So, my question to you is, what happened? Oh, that wasn't right.
Yeah, you put.
Gosh, what am I doing? Sorry. What happened? Nothing happened.
I had a mistake.
I caught it?
I thought you still made a mistake.
I caught it. That doesn't. You guys are ruthless.
I didn't say it.
I caught it. If I didn't catch it, I'll take that. Okay, so now what happened?
I don't know, there's too many arrows.
I know.
E is this one right here.
It intersection.
Where? Yeah, all these other ones, the vertices are at 0. The vertex moved down 2. What's the difference between A and E?
It's got a C that doesn't equal 0.
Right, C is not 0.
True that.
Which is an important thought. C is not your vertex. C is where it crosses the y-axis.
Very true.
But if your vertex is on the y-axis, then C will be your vertex. You're going to learn the differences of those in another lesson. So right now, if the vertex is on the y-axis, that's what C is. Well, what else? What do you know about D and E versus A, B, and C?
There, upside down.
Upside down. Okay, now look at the equations and tell me what you can deduce from it. Yes?
The D and E are both negative.
What's negative? The A is. The coefficient A is negative. That means it's going to go up and down. Alright, so you learned 2 very important shortcuts. If A is negative, it opens down. If it's positive, it opens up. Okay? C is where it crosses the y-axis. Pretty simple. Don't forget that the rest of the chapter. Okay? Alright, your assignment.
Assignment?
Assignment?
Yeah. Page 632, 1 to 23 all. Anytime you have odds, it's always all.